Topic 4, number 13, or number 1 on topic 4. I see a table, so already I'm thinking, even before I read this problem, I'm thinking I can approximate derivatives with the table. I can do rectangles or trapezoids, like Riemann sums. That would approximate integration. So let's see what they want me to do. And my guess is probably both, if I had to guess. The height of a tree is given by a twice differentiable function where h is in meters, t is in time, or t is in years. Selected value of h are in the table. Use the data in the table to estimate h prime of 6. Using correct units, determine the meaning of h prime of 6. Okay, h prime of 6, that should be an easy one because that's going to be change in h over change in time. At 6, or at time equals 6, so I should probably use the two closest to 6. So let's use 5 and 7. So 11 minus 6 over 7 minus 5. So that's 5 over 2. 2.5, but it's no calculator, so let's just leave it at 5 halves. The units I can get from, I don't have to know what the units are, they tell me. H is in meters, time is in years. Okay, so I've got the right answer, I've got the right units, but now I need to interpret what that means in the context of the problem. So, what does 5 halves meters per year mean? Be careful phrasing it that way. Like the 2 years between 5 and 7, it grew 5 meters, but that's probably not always the case. So we want to say something about at 6. At time equals 6, anytime it asks you to interpret, you should probably use the words rate of change, because that's what a derivative is. The rate of change of height of the tree is 5 halves meters per year. So you're just kind of putting in words what you already did. Part B. Explain why there must be at least one time between 2 and 10 such that h prime equals 2. Okay, if there must be a derivative, that sounds like a, let's see, what is that? Anybody know what that's called? There must be a time between 2 and 10 such that h prime is 2. Okay, well let's take some derivatives and let's see where the derivative is equal to 2, basically. I want to find 2 times I want to use 2 times so that the derivative is 2. Can you tell by looking which 2 would be a good, let's see, from 2 to 10, that would be 15 minus 1.5 divided by 8. That's not going to be 2. 2 to 5, this 1.5 thing is throwing me off, so it's probably not going to be that one. From 3 to 5, our derivative is going to be 2. So let's say from 3 to 5. T equal 3 to t equals 5. Delta h delta t, not derivative because we don't know that, but delta h delta t, the algebra rate of change is 3 to 5 is 6 minus 2 over 5 minus 3. That's why we pick that. 4 divided by 2 is 2. So the algebra rate of change is 2. What would allow me to say that the algebra rate of change is equal to the instantaneous rate of change? That's the mean value theorem. And things have to be continuous and differentiable for that to work. So no jumps, nothing crazy, and it has to be smooth for the slopes to match. So let's say that h of t is continuous because it's differentiable, because they told me it's differentiable, and differentiable. Spell it out, because it was given that it was differentiable. Therefore, by the mean value theorem, the average rate of change equals the instantaneous rate of change. So that means 2, which we just found, equals dh dt. Somewhere between, we use 3 and 5. And if it's that between 3 and 5, then it's obviously that between 0 and 10. So that was a mean value theorem question. We hadn't seen one of those in a while. This idea that average rate of change equals instantaneous rate of change. Part C, use a trapezoidal sum with 4 subintervals to approximate the average height of the tree. Oh, this is going to mess people up. The average height of the tree, it's like they're going to see trapezoidal sum and they're just going to do the trapezoidal sum, but that's not right, because the average height from 2 to 10 would be 1 over 10 minus 2, integral from 2 to 10, h of t dt. So the trapezoidal rule will get me this integral, or will get me an approximation for that integral. But don't forget to include the 1/8 out front. And I guarantee you a very common mistake on that is to do the trapezoidal rule right from 2 to 10. No problem, because that's what it told you to do. But forget to divide by 8. And my guess is there's probably 2 or 3 points for this problem, and you probably get 1 point for doing the trapezoid rule right, but you won't get the other points if you forget the 1/8. I'm a little pressed for time, so I'm going to pass on doing the trapezoid rule. I'll just remind you that the area of a trapezoid is base times average height. So you would do base times average height from 2 to 10. So you'd have to do all of them. Sometimes they're nice and, cut off your ends, but you got to do all of those. I'm just thinking if you were pressed for time on the AP test, that might get you 1 or 2 points because you set it up. You're not going to get the full points, but at least you set it up. And if you're feeling pressed for time, like I literally am right now because bell's going to ring soon, set it up, maybe move to the next one. Maybe the next one's shorter, or maybe you get the next one set up and grab 1 point off of it. So, I don't know. That's going to be rare. That's only going to be at the very end, but the height of the tree in meters can also be modeled by this function. I'm looking at this thinking, you know what, it might be wiser for me to just go back and do the trapezoidal rule rather than try to figure out what this is going to say. Like if I was taking the test, I'd probably, and my time was short, I'd probably be like, I don't know. I don't think that's worth my time for D. I'm going to go back and do the trapezoid rule because I know how to do that. But let's do D. The height of the tree can also be measured by the function g of x, where x is the diameter of the tree. When the tree is 50 meters tall, the diameter of the tree is increasing at a rate. So when g equals 50, the diameter, so dx dt, is 0.03 meters per year. According to this model, what is the rate of change of the height of the tree? So that's dg dt. Find dg dt when the tree is 50. When g equals 50. So I would have to take a derivative. Let's see, dg dt. Oh, goodness, I get to use the quotient rule. So gf prime, 1 plus x times 100, minus fg prime, g prime's 1, that's nice, over g squared. That is kind of a, like, again, the AP test throws you little Easter eggs once in a while, like to help you out a little bit. Once you distribute the 1 plus x, the 100x's will cancel out, and dg dt is 100 over 1 plus x squared. So that wasn't maybe as terrible as we thought. Oh, I did leave off something. Times dx dt, since we're taking a derivative with respect to t. And that's why they gave me that dx dt is 0.03. So I need to figure out x when g is 50. And then I'll plug that x in there, and that will get me the answer. So let's see. Multiply both sides by 1 plus x. So, oh, look at this. They were very kind here. So when x equals 1, g is 50. So dg dt at x equals 1 is 100 over 1 plus 1 squared times 0.03. And it didn't ask for units or explanations or anything like that, so done. And again, that took 11 minutes. I also didn't do the trapezoid rule, and I was also trying to go kind of fast. So I would say your assignment for today is do some more of FRQ5, because we'll work some more on 4 on block day. But kind of didn't matter. They're all due on Monday.